In recent days, the San Francisco Bay Area has been caught in a rare and troubling convergence of natural forces. Record-breaking king tides, combined with a powerful storm system, have pushed flood levels higher than many communities were prepared for. From Marin County to San Francisco's iconic waterfront, water has crossed boundaries that once felt fixed and reliable. Scientists are now warning that what unfolded cannot be treated as a one-off event. Instead, it may represent a glimpse into a new and far more unstable coastal future. When the bay pushes back. Just days ago, exceptionally high king tides surged across the Bay Area, lifting seawater well above normal high tide lines. Along San Francisco's waterfront, waves spilled onto sidewalks, flooded sections of the Embarcadero, and reached the steps of the historic ferry building. King tides are not new. They occur when the gravitational pull of the moon and sun align, temporarily raising ocean levels. In the past, they were often viewed as a curiosity, even an attraction. This time was different. Across the region, seawater pushed far inland. Streets, parks, bike paths, and public spaces were submerged. In Mill Valley and other low-lying North Bay communities, daily routines were abruptly disrupted as roads closed and neighborhoods were cut off. Scientists emphasize that king tides have long been considered previews of future sea level rise. What made this event especially damaging was the condition of the ground itself. Saturated soils and aging infrastructure left little room for error. Water had nowhere to go. A storm arrives at the worst possible moment. Before floodwaters had a chance to fully recede, meteorologists confirmed another threat moving toward Northern California. A strong atmospheric river. Atmospheric rivers are long, narrow corridors of moisture that transport massive amounts of water from the Pacific Ocean toward the coast. California is familiar with them, but timing is everything. This storm arrived while storm drains were already overwhelmed and groundwater levels were elevated by tidal pressure. Rainfall quickly compounded the situation. Streets that had briefly dried began flooding again. In many neighborhoods, runoff accelerated downhill, overwhelming drainage systems and forcing water into basements, utility corridors, and transit infrastructure. Emergency alerts warned residents of impassable roads, electrical hazards, and rapidly changing conditions along the coast. Wind-driven waves battered shorelines and cliffs as heavy rain continued to fall. What unfolded was not simply flooding caused by rain or tides alone, but the interaction of both, reinforcing each other in real time. Infrastructure under stress. As waters rose, the weaknesses of Bay Area infrastructure became increasingly visible. Much of the region's roads, utilities, and transit systems were designed decades ago, built for a climate where storms and tides were expected to arrive separately. That assumption no longer holds. Stormwater systems reach capacity far sooner than anticipated. Drainage networks designed to move water toward the bay became ineffective once elevated tides pushed seawater back inland. In some locations, flooding did not flow downhill at all. Instead, it surfaced from below. Water rose through manholes, utility vaults, and cracks in pavement, turning familiar streets into unpredictable pressure zones. Neighborhoods built on landfill or former marshland were particularly vulnerable, as saturated soils undermined ground stability. Engineers monitoring the situation detected subtle ground movement in several low-lying districts. While these shifts were small, they raised serious concerns. Each flooding event can incrementally lower land relative to sea level, quietly increasing exposure to future tides. Transportation infrastructure faced repeated disruptions. Portions of major roadways closed multiple times as water returned faster than crews could clear it. Rail lines and transit stations in flood-prone corridors required constant monitoring as electrical systems were exposed to moisture they were never designed to endure. Electrical substations, fiber optic networks, and pumping stations also faced elevated risk. Even brief saltwater exposure accelerates corrosion, shortening equipment lifespan and increasing the likelihood of delayed failures, problems that may not surface for months or even years. Perhaps most concerning was the realization that elevation alone no longer guarantees safety. Areas once considered outside flood zones experienced repeated inundation, forcing planners to reconsider assumptions that have guided development for generations. A compound crisis takes shape. Scientists refer to this kind of convergence as a compound event, multiple hazards overlapping to magnify overall impact. High tides alone strain shorelines and seawalls. Heavy rainfall alone overwhelms drainage systems. When they arrive together, the system never has time to reset. Water that should drain outward is forced back inland by elevated tides. Rain that would normally disperse becomes trapped, pooling in streets, underground corridors, and building foundations. Each component intensifies the others, creating effects greater than the sum of their parts. What concerns researchers most is the lack of recovery time. Even when visible flooding recedes, groundwater levels remain high. Foundations stay saturated. Infrastructure remains stressed, leaving communities exposed to the next surge. Climate-driven changes are increasing storm intensity, while sea level rise elevates the baseline from which every tide begins. Events once considered rare are now occurring closer together, narrowing the window for recovery. Human impact and uneven burdens. Behind the flooded streets are real human consequences. Residents deployed sandbags, cleared storm drains, and altered daily routines as roads turned into waterways. Transit delays rippled across the workforce. Schools and businesses made last-minute decisions to remain operational. The burden was not evenly shared. Hillside neighborhoods faced landslide risks from saturated soils, while low-lying and lower-income communities endured prolonged flooding and isolation. Some residents experienced displacement for the second or third time in recent years. Mental strain mounted as unpredictability replaced stability. Events once labeled extreme began to feel routine, eroding confidence in long-term security. Adaptation or retreat. As waters slowly receded, attention shifted from emergency response to long-term reckoning. Cleanup revealed salt deposits, debris, and lingering pools, evidence of deeper drainage failures. Engineers documented foundation shifts and infrastructure fatigue. Scientists and planners now argue that rebuilding exactly as before is no longer viable. Discussions are accelerating around redesigned seawalls, restored wetlands, expanded buffer zones, and updated building codes. Flood maps are being redrawn as risk boundaries move inland. The central question facing the Bay Area is no longer whether high water will return, but how often and how prepared the region will be when it does. The collision of king tides and atmospheric rivers has reshaped how risk is understood along the bay. What unfolded was not a single disaster, but a warning written across streets, shorelines, and infrastructure. The water has made its intentions clear. What happens next will shape the region's future.